Hello everyone! This is the last video for lesson number 2, the law of sines. In the previous video, we're able to identify the number of triangles that can be formed in these given situations. You might want to check that video. And we have already identified that for number 1, there can only be one of SSA oblique triangle that can be formed, as well as in number 2. Number 3 is not an oblique triangle since it is a it has a 90-degree angle. At the same time, with the clarification from last video's processes, there can be no oblique triangle that can be formed with these measurements. And for number 4, there are two. And we are going to solve the two triangles here in number 4. So since we have identified here in these SSA situations, especially for number 1, that it has only one triangle, that we can now safely use the law of sines because we have no other possible situations, or we are not going to make a mistake by completing a triangle that is nowhere to be found in the first place. So for this, we are going to use this law of sine still. Please don't forget that the law of sine uses ratio between the sine of a given angle and its opposite side with another ratio like this. Make sure that the opposite sides are placed on the denominators if they are on denominators, and the sign of angles are on the numerator. And this is as well sine C, which is C. Here we're just so lucky that all of our expressions here are expressed in A, B, and C's. But then again, if there are situations where our vertices are no longer A, B, and C, say another alphabet letter, that would mean that the notations may be changed. At the same time, the legend for their opposite sides will also be changed. But that's not anymore our concern here. Our task is to solve for number 1. Notice that we have a pair here of a given side measurement and an angle, and that's what we're going to use to get the remaining measurement. So for us to solve A, angle A for in this case, because we have side A measurement, let us pair sine C over C equal to sine A over A. And in this case, we can notice that we are going to solve now for an angle. Unlike the previous two situations that will use law of sines, which are AAS and ASA, two angles already given, and hence in solving the remaining angle, we are just using the triangle angle sum theorem with the difference of the sum of the given to get where we subtract the two measurements of angles to get the remaining three, subtract it from 180 degrees according to triangle angle sum theorem. Here, we are going to solve angle A in this sense. So let us try to substitute the values first before we could actually get it. So sine C, you have here sine C, which is sine 47 degrees over 20 is equal to sine A over 13. Applying symmetric property in the fundamental of proportion, you will get this expression. Sine A is equal to, that sine, okay, is equal to 13 times sine 47 degrees all over 20. Okay, you might want to derive this if you would like to. But we are not looking for sine A. We are looking for angle A. And this time, we are going to use the inverse of sine or the arc sine because we are just looking for angle A. And hence, if we're going to do that, the measurement of angle A be equal to the inverse of sine or sine inverse with the value of this expression, 47 degrees, that's degrees, all over 20. Okay, so this is how we are going to do it. We are going to use a sine inverse. But where should we locate the sine inverse? Now let us try to use the same calculator that I've used in the previous video, which is this one. This is available on the internet. You might want to use this if you would like to. You're allowed to do so. And if you want also to use your calculators, your hand-on calculators there, you may also do that. But one thing is certain here. When we try to apply the values here, make sure that we are not going to round off this value before multiplying to 13 and with the rest. And we are not also going to round off the entire value before using the sign inverse. We need to make sure that our rounding off process is done at the end of the computation. In that case, how do we input this? Let us try to input first this expression, and considering that this is a rational expression, so we have a numerator and denominator. In doing so, let's do it like this. Let's make parentheses to make sure that the numerator is separated from the denominator. So you have 13, and that's a product. So times sine 47 degrees and close it. That's for your numerator. Okay, we're not yet done. Because if you're going to use this one to and divide it to 20, some of you might just use 9.5 or 9.51. It might not be the same as the actual value. So my suggestion here is just to continue the process and use division by 20. Okay? So this is now the actual value for this expression here, and it should not again be rounded off because we are not yet done with the process. So what is the suggestion here? I would like you to save this by clicking equals, and once you do that, it is now saved as the previous answer. What is the importance of this is because when we try to get the sign inverse later, we are just going to use the actual answer that does not limit to its value until whatever decimal place would that be, because we are going to use the exact value of the result. How are we going to do that? Here is the sign inverse. So once we have clicked again equals, it is now saved as the previous answer. To continue, and instead of saying sign inverse of 0.48, we need to use the exact value by doing this. Sine inverse or the arc sine and click ans. This is actually a record of the previous answer. Our previous answer was actually the value of this expression. As we click equals and saving it, let's do the same here. Click answer, and that is now using the value that should be used. And it doesn't even discriminate the rest of the decimal places because we are saving the actual result. This is the time that we could now round off into two decimal places because we will no longer use other processes that will pertain to angle A. So the measurement of angle A is now 28.38 something, but when we round it off into two decimal places, that's 28.38. And if we're going to do so, please use approximation. So the measurement of angle A is approximately equal to 28.38 degrees. Again, we use approximation because we are rounding off the result. This is now the measurement of angle A. So we are now done with the second angle, okay? And we could actually use it to get the other side, okay? And at the same time, we could also use it to get the remaining angle. And let me just solve it first because it's easier for us to understand or to follow a process on the same type of geometric figure. So we have measurement of angle C and measurement of angle A is already given. So the measurement of angle B, according to the triangle angle sum theorem, states that the sum of the measurements of the three angles must be equal to 180 degrees. Hence, we will get the measurement of angle B by subtracting both measurements, the given measurement of angle C and the computed measurement or approximated value for the measurement of angle A from 180 degrees. So subtract 47 degrees and subtract another value 28 point, sorry, that's 0.38 degrees. The measurement of angle B. So using the same calculator, we'll have 180 less 47 minus 28.38, and you will get 104.62 degrees for the measurement of angle B. So 104.62 degrees. This is the measurement of angle B. So we are done with the second angle, and we are to proceed to the remaining side measurement, which is side B. And we are going to use the angle here to solve sine B. And the another advice that we can use here is, of course, now that you have measurement of angle A, you might get tempted in solving the measurement of angle A, pair it with A here just to get the measurement of B. Right? My suggestion here is this: we need to understand that we could always use the given pair, because if you're going to use the pair of angle A and side A with the measurement of angle B to its side B, you're actually using two approximated values. Well, it's still good because you're approximating them, but as soon as you proceed to more computations, some results might not be as true as the exact value. So you're gonna still use the same given here, so since we have another pair, and only use this as an approximated value to get the side B. So we will have sine angle C all over side C is equal to sine angle B over side B. And applying or manipulating or substituting the values, you will have sine, that's sine, 47 degrees all over side, which is 20, is equal to the sine of B. In this case, we have this value, 104.62 degrees all over B. Manipulating both sides, you will get this result for measurement of B. You have 20 sine 104.62 degrees all over sine 47 degrees. Let me check. You're going to multiply B here, both sides, 20 divides sine 47. So you will have this result. And we can now approximate its value using, again, another calculator, or the same calculator, pardon. And let's input this all at once, considering the difference or the use of parentheses for numerators and denominators. So you will have here, sorry, let's click AC to remove everything here. So you have parentheses 20 sine 104.62, close it. Okay, I need two parentheses because the first parenthesis is for the angle and then the second is for the complete figure. And then divided by sine 47. This is the result. And when I click equals, you will have 26.46. Round it off into two decimal places. So the final result is B, approximately equal to 26. Let me check it again. It's approximately equal to 26.46. So this is now the measurement of side B. Now, for this very long process, how would we know that our answer is correct or not? Always consider this concept that the side measurement opposite the largest angle is actually the longest. Let's look into the consideration here for this. So our side C is 20, side A is 13, and now our solved side B is 26.46. The largest or the longest side, I mean, is 26.46, which is B, to be followed with C and A. That should also be the pattern for the measurements of angle in descending order rather. Again, BCA. So let's look at B, 104.62 degrees. C is 47 and A is 28.38. In this manner, we have observed that the relationship between the angles and the side measurements follow the same order. So this is now the correct value. So the process is now correct. Let's proceed to number 2. And number 2 here, we have B, A, and angle B. We have another pair of side measurement and angle, which is very convenient for us in using the law of sines. And since we have assured that in this given, in the previous video, we only have one triangle, so let's proceed and continue with the process. Since the next side measurement is A, therefore we are going to look first for angle A, or the measurement of angle A. In this case, let us have the sine of 97 degrees all over the measurement of B, which is 45 units, must be equal to the sine of angle A over 39. Same thing with number 1. We are looking for an angle in this pattern, so we're going to use the sine inverse. But first, let's just try to manipulate this. You will get here, using symmetric property in the fundamental law of proportion, sine A is actually 39 times sine 97 degrees all over 45. All right. So, and then the sine inverse to get the measurement of angle A. The sine inverse, or the arc sine 39, sorry, that's 39 sine 97 degrees all over 45. Same as earlier, please try to make sure that we are approximating, and hence use the calculator when we input all of this. So we use the same calculator here. So we have to compute this. So let's have click AC. So you will have parenthesis 39, sorry, 39 sine 97, close for the angle, close for the whole complete expression on the numerator, divided by 45. Okay, just like that. So we have this result now, and make sure you are going to check it if you would like to. 39 times sine 97 divided by 45. And when you click equals, that will be saved as your previous answer. Okay, this value here, and make sure you use that as you take your sine inverse and click answer and equals again. So your final answer for the measurement of angle A in two decimal places is 59.34 degrees. So you have here 59.34 degrees. Let's check it again. That's correct. This is now the measurement of angle A for number 2. We could use this to get the remaining angle. In this case, it's angle C. Earlier, it was angle B. Again, using the triangle angle sum theorem, the measurement of angle C must be equal to 180 degrees, the total of the three, less the given and the solved value here. So you have minus 97 degrees minus 59.34 degrees. And it's approximately, again, measurement of angle C is approximately equal to, again, calculator to the rescue, click AC, 180 degrees less 97 less 59.34 equals to 23 rather, 0.66 degrees, and that's just an approximation again, 23.66 degrees, right? Okay. Then we need to follow this by measuring or getting the value of the remaining side, which is here, side C, but using again the original pair instead of using two approximated values. So for this, you will need to use the same. So you have here sine 97, that's your given angle, over 45 is equal to sine C, angle C, 23.66 degrees all over the side measurement C that we would like to solve. And further, this would become applying all properties or fundamental law of proportion. You will have here C is equal to 45 times sine 23.66 degrees. Again, cross multiply, so 45 will be here, C will be there, and then divide both sides by sine 97 degrees. So look at what happens here, more or less similar to what happened here earlier. So let's use the calculator to get the exact value of this, or again, approximation, because 23.66 is also approximation. But we could attack it as ones using this calculator here. So let's click AC, parenthesis for the numerator, 45 sine 23.66, close the angle, close the numerator, divided by sine 97 for the denominator. And when you click equals, you will get 18.19. And it's no longer degrees because it's a side. 18.19 units. Same checking. Let's see the arrangement of the angles or side measurements, depending on what on which you would prefer, but they must have the same arrangement. Let's talk about ascending order. The largest or the longest side is B. So you have here B. It should start with B, and then A, and then C. Let's look at the measurement of angles if it follows the same concept. The largest value of angle is 97. That's angle B. That's correct. To be followed with A, 59, and finally measurement of angle C. So it follows the same concept. Therefore, the measurements for number 2 are all correct. On number 3, you could try to solve this on your own, but we are now safe to say that there can be no triangle here per previous video, the practice exercise B. In short, in this manner, we cannot determine this. So let's just simply here say cannot be determined because we don't have here a triangle that would represent all of them. Okay, so let's proceed to number 4, because number 4 is the problem with identified two triangles as we have in the previous video. So this is actually number 4 here. Let me see if I have enough spaces. Let me increase here. Yeah. Okay. So in number 4, according to our previous video, you might want to review on that. We are expecting here two different triangles because it meets the criteria for two situations that can be drawn out from it. If you cannot remember what was it, let me reshare to you that ambiguous case that we have used last time. This one here. So measurement of angle B, but A in this case. Please not be confused with that because we're using here the GeoGebra given here by Patrick Kennedy is using the general form where A is the angle. Okay, so it's 12 degrees. The opposite side, which is A here, and B on the given on our practice exercise is 8. And B, which is 12 here, but it was C. It's actually C on our given. But again, please don't be confused with that here. So we are having two different triangles. The first triangle is triangle A, C, B2. This largest triangle here, where angle A is 12, B, which is 12 here, or in this case, angle B, and then C here, and the opposite side, that one, sorry, whoop, it cannot be, but it's like this one here. This is the largest triangle. But we also have another triangle that can be drawn from it, and that's actually this triangle here. Up. This triangle here, which has a darker shade of blue for here. So we have two triangles, and in short, we have two situations here. Which do we prefer to solve first? Yes, that's the question because we are going to solve both of them. Let me try to copy this one here so that we will not have any repetitive problem here. So copy using snipping tool. Let me transfer it here. All right. So let's try to solve first the measurement of the angle. Of which angle? Because it's since it's now safe for us to have this, let us try to denote this as this is our triangle 1, this smaller, and the largest is actually your triangle 2. So you will have here triangle 1. So you have here AB or ACB2, sorry, ACB1, okay? And then you have here the second triangle, triangle 2. Okay, again, don't be confused with the my notation. So we have two situations here. But how do we solve this? We could start by solving first the relationship of or solving the measurement of angle C, looking at this given by law of sines. And whatever the result later on, that is where we are going to anchor our analysis. Okay? Let's just solve it in the first place. So let us try to say here, let me move it here for a while. All right. Okay. Let us solve first the measurement of angle C. So it would be sine B as the given over B must be equal to sine C, angle C, all over small letter c here. Okay. So let's try to substitute the value. You have sine 12 degrees all over 8 must be equal to the sine, that's sine of C all over 12. Let us try to apply the same process here in number 1 and number 2 where we get the sine inverse. So applying the correct processes, you will get here sine C is actually 12 times sine 12 degrees. That's degrees, sorry. Degrees. Okay. All over 8. And the measurement of angle C is actually equal to the sine inverse of the exact value of this expression here. Okay, that's 12, sorry, all over 8. So let's try to get the value of this, and later on, whatever the result, that is now we are going to anchor our analysis. Since there are two triangles to be solved, we need also to identify the correct use of the value of the angle C later. So if we have this, the measurement of angle C is approximately equal to something. Let's use the calculator, okay? Same calculator here. Let's click AC to remove everything. So you will have numerator 12 sine 12 divided by 8. Okay? Click equals to save it as a previous answer. And then sine inverse of the ans. You will get 18.17 degrees. Okay? 18.70 degrees. Round it off into two decimal places. So it's again 18.17 degrees. This is the measurement of angle C in this given figure, this given here. So this should be the correct answer, and this is the correct answer. Now, what is this value for? Is this a measurement of triangle 1 or triangle 2? Let us look into the perspective of triangle 1. Again, it's not using correct letters, so let me just rewrite this. So the given is angle B. Okay, this is C, right? This is actually this side here, this side, including this side here, is actually given as 8. Okay, that's actually B is equal to 8. Please not be confused. Okay, C is this one here. This side I'm talking about this. So let me rewrite this one. Right, this and this side here. Okay, we have B is equal to 8. So that we will have the same notations. Okay, so see here. So the notations here is not anymore B1. So it's C1 and C2. This is now your angle A because B, yeah. So this is C, small letter C, side C. So its opposite angle should be C. So either of this or that. So the question right now is, the angle of 18.17 degrees is located where? Is this the angle or this angle here? Okay. Notice that the value solved is 18.17. In short, it's an acute angle. So it represents which angle? This is an obtuse. This is an acute. So the angle here solved 18.17 is actually the angle of the largest triangle. This one here. this area here is your 18.17. So looking back here in our situation, let's list all values, okay, in the first place. So B is given, C is given, the measurement of angle B is given. So we're also that's also the same given with the triangle number 2. What we're looking for is the measurement of angle C, sorry, measurement of angle C here, and the measurement of angle C. But again, the 18.17 is for the largest. So it's the triangle number 2. That should actually be C2, C2, C1. So C2 is equal to 18.17 degrees. Right? So we are actually solving, this one is actually for the second or the largest triangle here. Do not be confused with this, okay? This is just a height. Let me remove this so that there will be no confusion. So the two triangles are this largest, not this one. Okay, this is isosceles yan. The largest and the smallest here. Okay, 18.17. With this, we can also solve here the measurement of angle A. And which A are we referring? The largest, this one here, A. The measurement of angle A. But since it's triangle number 2, let's just use triangle number 2, okay? Okay, so you have here, this is actually computed, same as this process here, right? We have 180 degrees less, you have 12 degrees less 18.17 degrees, and the value is approximately, remove 100, sorry, 180 minus 12 minus, again, that's degrees, okay, 18.17. So 149.83. So we have 149.83 degrees. This is the measurement of angle A. This is also another proof in saying that triangle number 2 is the largest, because it talks about the entirety of this, not just this angle here. Okay, so the entirety. This is the measurement of um, angle A in the second or the largest triangle. So how do we refer this later? Because with this, we can solve definitely the remaining side, which is A. But before we go to do that, let's try to consider what will happen here in angle 1. Now that we solve the two angles for the largest triangle, let's just finish this to get the remaining side, which is A. The A here is the entirety of this, because this is the side opposite the largest angle A here. So we are going to use the law of sine using the same given pairing. So you will have this result here, sine, right, B all over B is equal to sine A, this one here, A sub 2, right, all over small letter A, and let's use sub 2 because they are part of the second triangle. Okay, so I'm manipulating. You will have here A, the value of A is B, which is 8 times sine, the value of angle A here, 149.83 degrees, all over sine B, and B earlier is given as 12 degrees. All right. So the measurement of the second, or the last side rather, is approximately equal to, numerator, 8 sine 149.83, close, divide by sine 12. So you have 19.34 units. 19.34 units. So you have 19.34 units. And we have now solved the three unknowns, okay, for the largest triangle in that situation. Why do we have two situations? Again, explained already in the previous video. You might want to check that one. And since we have two triangles here, we are going to solve the rest. So again, the thing here is once you have solved the first angle, you need to examine where is it for. Is it for the smallest or the largest? Looking at the situation itself. This is actually obtuse, acute, so you can decide on your own. Now, what do we do to solve the second or the smaller triangle here? So we are still going to look for the measurement of angle C sub 1. Let's use another color. The measurement of angle C sub 1. We are looking for this here. And if you're going to use the same concept earlier, pairing, you will still get the same value of 18.17 degrees. Because the same value for B, the same value for angle B and side B, and the same value for side C will just yield the same measurement of angle C. And then again, 18.17 is here, not this one. How do we consider this? Listen to this one. Looking back to our ambiguous case here, if I'm going to play this again, you would see that this side here is actually equal to that. Okay? Both of it represents the opposite side of this angle 12, which measures 8. As you can see in the problem, okay, the opposite side of measurement of angle B, but A in this case is 8. So it represents both here and here. So my point of saying this is this side is equal to that side. Okay, going back here, this side here is equal to this side. In short, this is also 8. And this makes this area here, okay, not the oblique triangle we're referring to in a previous example and the triangle we are solving right now. This triangle here, let's use pink. This triangle here is an isosceles triangle because this side is equal to that. And an isosceles triangle theorem, if you can still remember, it tells us that this angle here, the base angle, is also equal to this base angle. So this is 18.17. This is also 18.17. But 18.17 again is not the angle for C1 because this is what C1 is. Now that we have known that this is also 18.17, notice the relationship between these two angles. They are forming a linear pair. If you can remember linear pair in your grade 7 and grade 8, linear pair or an angle for or two angles forming a linear pair are supplementary, or in short, they must sum up to 180 degrees. So where do I go right now? What is my point? My point is this. I'm going to make it simpler to you. Whatever value you have solved earlier for the measurement of angle C, since we have verified it for the largest, that's already okay. To get for the measurement of the other angle C is using also this one, but with the response to its difference from 180 degrees. So simply subtract whatever value you will get. Okay, 18.17 degrees. Okay, so basically, you're just interchanging the values for your two angles here. Because angle C earlier is 18.17 as solved and as analyzed. And the measurement of angle A is like this. Okay? So we have to solve it here. And it is approximately, the measurement of angle C1 is approximately, okay, let's do this, 180 less 18 point, sorry, back, 18.17, sorry, 17, and you will have 161.83. This is 161.83 degrees. This may be too large, but don't worry, since your angles are too acute in nature for the first, and acute as well here. This is the measurement of angle C. Okay? Again, the difference between the two, the first is whatever you solve. The second is its difference, or the 180 minus that one. And then the measurement of angle A will follow with the same process. So you have 100 80 degrees less the given, okay, notice here, 12 degrees less 161.83 following the triangle angle sum theorem. By the way, I've keep on repeating terminologies in geometry, trigonometry, and even some points in algebra because we need to apply everything that we have learned so far to understand these situations. Pardon. So the measurement of angle A sub 1 is equal to, you have 180 degrees, sorry, let me click AC, 180 degrees less 12 less 16.18, 151, sorry, that's not point 18, let me go back, 161.83, that's 6.17 degrees. So 6.17 degrees. Okay, so this is now the measurement of angle A. And finally, use the same concept to get the remaining side here. You have sine B over B. So you have sine A1 over small letter A1 to get the side of the first triangle, which is here, the smaller oblique triangle. So applying the same concept, you have A sub 1 is equal to the value of your B, which is 8, sine angle A, which is 6.17 degrees, all over sine B, which is 12 degrees. So this is now approximately equal to, okay, we're almost there. So AC, you have 8 sine 6.17 divided by sine 12. Okay, so that's 4.14. Okay, so you have 4.14 units. Again, what was problematic here is just we have two triangles in this situation. So always consider looking at the different perspective. But of course, we could always check if we would like to. For the first triangle, the largest angle or the longest side, let's look at the longest side. Longest side is C, followed with B, and then A. So you have C, B, and A. Let's look at the angles. Again, this is not the angle C for the first triangle because that's for the second. Okay, don't be confused with that. Okay, so angle C is here, 161.83. Yes, the largest, followed with B, which is 12, and finally A, which is 6.17. That would mean the results here are all correct. Now, looking into the different perspective for triangle number 2, the sides or side measurements we have. Okay, the C is 12, B is 8, but A here is 19. So you have A is greater than C and greater than B. So looking at the measurement of the angles, let's check. The measurement of angle A is 149.83 compared with 18.17 and 12. So it follows correctly. That would mean the answers are all correct. So this is how we solve SSA ambiguous cases. We're just lucky to have numbers 1 and 2 to only have one triangle, so it's very clear to that. Number 3 cannot be determined. But in number 4, since we have two triangles, we are going to solve both of them, and they are separated with the different values here coming from the same given measurements. So please use this as part of your review, and the next video will talk about different situations and probably would use a different set of formulas. Hopefully you have enjoyed watching this. Goodbye everyone.